Thank you very much, Alexander. Thank you very much, IIUFRO, for having me here. It's a great pleasure, and I'd like to wish you all a very good morning to the people at home and all the participants here. Great to see you. Well, where to start? Probably the best to start where Daniela ended. And this is actually to take the title of this conference serious, and it puts collaboration in the center. And if we as the scientists think about collaboration, then it's of course we think about the forester talking to a biologist or to a hydrologist, etc. And it's not so much the collaboration which I think we are really lacking still a bit. That is the collaboration between science and the people, the public. And with that also, of course, this strong link to policy. So I'm very grateful that, we had this perfect coordination here, that Daniela talks about this very important policy part, the SDG 15 in particular. And I can take over the more simple part, let's call it, and concentrate a little bit on challenges that the forests are facing and opportunities. And finally, let me also thank you, Daniela, that you tested all the equipment. It should work now. All right, good. Then, where are we? And this was mentioned, of course, and we all know it. Forests have never been so much under threat. And at the same time, the expectations were so high. Forests should fix everything, almost everything, or at least they can fix everything. And as foresters, we know they can. But of course, there is still some way to go. And I think we need to look a little bit more careful into things that we certainly all understand. But the issue is also to bring these knowledge and insights together. And one of the basic understanding, and I'm not getting tired to repeating that, is to show that we have a certain problem. And the last IPCC report, AR6, indicates that very well again. We are, now I'm testing the pointer, we are with our emissions here. And unfortunately, our pathway is more in that direction than into this direction. So here is zero, and this is what we have to reach quite fast as a society. Here is the curve we need to hop on much faster than we can imagine. And this is the range in about 30, 40 years where we have to reach zero emissions as a society globally. And this is the biggest challenge from my point of view that we are facing now. And the closeness to policy is evident here. So this is something we cannot avoid. And large part of fixing this problem is put currently on forest, land use change, agriculture, on the land, let's call it. Okay. So, and now some of the real challenges, and some here I have to excuse myself that I only look at the more climate related challenges, because those that were mentioned by Daniela already, restoration, deforestation, for instance, this is a very direct human cause, and I would like to look into the more indirect ones. So it will be a selection. Okay, a very recent research has done a beautiful exercise. It is to take a lot of knowledge that we have from many models, models that look into disturbances like, for instance, bark beetles, maybe also fire, into climate change trends that concern precipitation, temperature, etc. They have put all these insights together and created a global climate risk hotspot map for forests. And you see the resolution is not the best. This is due to all this mixing of different models and types of models and targets of the models. You will see it's also a little bit splashy, but what it should tell you is that there is no place on Earth where we don't have a risk existing and or coming up. So this is very important, the global view. On the other hand, we also need to know what are the consequences of these risks? How do these risks look like in particular cases? And here are some maps that show parts of Europe and that, for instance, address the increment of the forest. And you can see that under RCP 8.5, and for those who don't know what that means, that was this very steep going up curve, which I've shown before from the IPCC graph. This is basically where we are on. This is business as usual. Under these developments, models show that particularly here from the southeast, a quite severe decline of forest increment is to be expected. We see here the absolute on the larger graphs here over the time, and these are the deltas which are given here, and we are talking here in the red areas about quite substantial losses of going down from up to 9 cubic meter per hectare of increment to 7 and 6. So this is really substantial. Yeah, this is something very important. And this is not the only problem. We know that climate change is mostly driven by increasing temperature, decreasing precipitation. There are other consequences that immediately follow a stressed forest or plants under stress. And this is shown in that picture. That is the development of the burnt forest areas in Europe under these different former IPCC scenarios. And we can see that even in the scenario that reaches the Paris goals, this is that one, 2.8, RCP 2.8, we will find a slight increase of forest area burned. But if we really follow our present pathway, we will end up not at 250,000 hectares burned area in Europe, but we will end up at easily the double area. So this is a real problem we are facing. And unfortunately, again, going back to IPCC, we are on this trajectory and we have to think about that. So it's not only an increment loss, it's an addition of this problem that we will lose forests to fire. And of course, we should also know not how the curves look like, but it's always interesting, particularly for collaboration with the public, for awareness building, where this is happening. And it is very clear that we will face an increase of a burned area, but also an increase of the severity of the type of the burning. It will go more into crown fires, where it was more into ground fire. We have seen the effects yesterday at the excursion in the Rax area, where in global dimensions, small forest fire happened to Austria, which was a huge event, very expensive, very difficult to put out. And here we see that in these areas where it's already burning now, Mediterranean, mostly all the red areas, it will burn even more. You see how dark this gets. This means that from each of these pixels, more and more area is burning. And also countries in Scandinavia will not be out of reach for forest fire. It will reach even UK. So it will be everywhere, and we have to think about what to do and how to deal with it, and in the end, what forests can contribute. A very important thing, and here I would like to address the heroes in Ukraine, and very eminent researchers, forest researchers are among the audience, that there is an additional problem that we cause to these forest fires that are basically a consequence of climate change. This is the present war in Ukraine. And we see here a night picture in Chernobyl, the exclusion zone. This is a special area that is closed because of radioactive contamination. And everybody who knows what happens when a fire starts and goes up to the ground, there's an incredible turbulence that soaks up basically radionuclide particles into the air. And this cloud can come everywhere. So it will move to Austria, it will move into the other direction up north, depending on how the weather situation is. And this is now really a very dangerous situation. And the increase of fire due to war effects, bomb shelling, which immediately ignites a very dry forest, is tremendous. And we have to help wherever we can here. The whole situation doesn't look much better. You will remember the other curve, but this is globally. Just that the order of magnitude here on the axis is not hundreds and thousands, but it is millions. And the same trend, we will go from about 90 to 100 million hectares that we are losing every year globally to forest fires, up to almost the end of the graph here, maybe 200 million hectares. So we will double, and we have to do something about it. And unfortunately, we are very late with our mitigation efforts. And this is where the hotspots by the end of the century will be located. Of course, in the boreal north, but particularly the fires will also go into the more tropical areas. And to fight fires in these areas of the tropics or very remote areas of the boreal is a very difficult thing. Okay, so, but enough of these very important challenges. There are luckily also opportunities. And again, this is just a selection to open up again your minds, to remind what can be all done and where we can help the forest to handle this quite difficult situation. And luckily there are tools that we didn't have quite some time ago. That is just to mention citizen science, crowdsourcing. Again, it's this collaboration with the people, with the general public, where they help us through their mobile phones to collect data which we cannot yet measure or identify in any other way, or it would be extremely costly. This group does it because they are interested and it's for free and we can use it. And for instance, here we made a suitability modeling based on this crowdsourced data that improved our national forest inventory for the Alpine countries here. Yesterday, we have seen the Alps. And combined this with climate and forest modeling, and we can see how the individual tree species, and we just picked some of them, Norway spruce, you saw yesterday also quite in trouble because of drought and bark beetle, or a potential substitution tree species, Douglas fir, can develop over time. You see basically the historic suitability of these tree species in the alpine space on the upper part of the graph of the slide here, and the future suitability here on the lower part. And we see that Norway spruce will really have to fight. We will see that also Douglas fir is not what we were hoping for in terms of suitability. And black locust, which is another beast, quite invasive, will be happily spreading into areas that are not suitable presently. Okay, but what means suitability? Suitability, of course, doesn't mean that there is no spruce growing anymore. This does not mean the same, but it means that we have to look into details, and here is a higher resolution graphic that shows, for instance, the suitability of the Norway spruce in the historic times. On the left-hand side over the Alpine bow, you see here, this is Italy, this is Croatia, and Austria is somewhere in here in the middle, with Vienna here at the eastern edge of the Alps. And we can now compare the different scenarios and different species online with Google Earth tools, and have a very nice visualization, which is also important for this communication and collaboration. And if we have a look at, for instance, this Rubinia pseudacacia, black locust, and I show you here in a video, I hope it works, how you can move this curtain of this Google Earth engine and basically check how it has been before and how the suitabilities can change. And again, suitability doesn't mean that it's not growing, but there might be big effects regarding their increment. And here again, we are back to the Norway spruce, and now starting again the video and the curtain. This is historic increment, so up to 9 cubic meters per hectare, a quite good location for Norway spruce actually. And this is 2,100 under an extreme development scenario. Unfortunately, we are on that scenario. And this is how we are losing increment. And with that, of course, suitability is not optimal anymore in the places where it has been. Okay, but again, I have to stress IPCC. And again, I have to come back to the idea that forest can solve it all. We see here emissions and how the emissions should be distributed over different sectors in the future in order to reach net zero emissions. And everything that is green, you can basically refer to the forest. And you see all that area, and that means that the forest is planned to be the probably most active player in order to reach net zero. And in order to reach net zero, we have even to provide negative emissions. That means we have to go below the zero line with our land use and land use change activities, mostly in the forest. And here I've put that together. So we are basically, in order to reach this 1.5 maximum warming, we have to reach dimensions of 30 to 780 gigatons CO2 through CDR. CDR is carbon dioxide removal. That is these negative emissions. And this should come from forest. And this is a very, very huge thing, as I will try to show. And how we can do it, this is shown here by a few simple graphs. You see atmosphere, land and ocean as the buffer in between, and the geological contribution of the soils. And climate change, basically, you take fossil fuel out of the soils, out of the geological formations, and it's added here to the atmosphere concentration of CO2. With bioenergy, we have this more or less neutral situation, that we don't take it out from the geological formations, but we take it from the land and have these emissions, and this is considered to be neutral. And I think this is also a very important message here to whatever Brussels is at the moment for Europe thinking about, etc. Yeah, let me just show the next option. This is carbon capture and storage. Carbon capture you can apply on any fossil fuel energy generating plant. You capture the carbon and put it underground, and by that it is comparable to bioenergy because it's also supposed to be neutral. And the only way to reduce atmospheric carbon in these systems, land-based, is to combine bioenergy in its neutral definition with CCS, and by that take the CO2 concentration out of the atmosphere and put it back into geological formations where it belongs to. And this is the magic that forestry can, and the whole forests can contribute here, in addition to some other technologies, but this is probably the most important thing, and we can compare here prices and potentials. We were talking about BECCS at reasonable prices and huge potential, actually. There is afforestation, and then we have also something like biochar, soil carbon sequestration, and direct air capture is a very technical solution. This is not land-based, but it is very, very expensive. And therefore, still all the model runs that IPCC can show has highlighted these land-based negative emission technologies because simply the technology exists and they are the cheapest solution. So this is something we have to have in mind. Nothing else can offer us this. And we talked about high prices, etc. So it will not become easier to finance our climate change mitigation that is needed. And of course, there are shortcomings. Yeah? Technologies exist, everything could work, but we have to take care of several things. And there's just one keyword: biodiversity. We have to take care of food security. We have to take care, etc., etc. Nobody said that it will be easy. Okay, but last not least, I also have to come back to this afforestation, because this was also part of it. And people think, well, the world thinks, many policymakers think that afforestation is one of the best solutions. And yes, this is where a forest can grow globally. It can. So we have to search an area where we still can do additional afforestation. So this additionality effect needs to be there. And this is the global grasslands, where we might go into and turn grassland into forest land. But yeah, it's very difficult. Afforestation on grassland, you still need to have a certain minimum growth, and you can see what we can do here. The darker, the better could be the increment, and with that also the carbon sequestration on grassland. Yeah. Okay, so there are a few spots where we should look closer into, but then again, Daniela said it, there are people living on the ground making their subsistence from, and it's not so easy. This is our very top-down perspective and modeling perspective. And the other idea is that we use cropland, because on cropland we can, for instance, introduce shelter belts, etc. So there is a certain potential also on cropland without endangering food security, even by adding additional benefits here. And these are the areas where we could do this best, obviously. So putting that all together still doesn't talk about very important things like biodiversity, the carbon, of course, and water. Water is absolutely key, of course, also here. And there is also a nice map that has been published in, I think it was Nature last year, where the authors have tried to put together these three major components and try to optimize. Either we do all at the same time, where should we go, where are the important areas, where are the hotspots, or do we favor carbon over biodiversity or biodiversity over water? So you see very difficult decisions actually that you have to take. And when we now put this all together with our thinking of where we can do afforestation in a safe place, then this is a rough outline where red means no-go area. This has to be absolutely untouched. Where green means this is an area where we can think about, where we can talk to the local experts, to the local people, and what do you think about afforestation activities in these areas? And blue is something which will be quite difficult. You see, Sahara is included in that area, etc. So there we have to probably find additional possibilities. And after all, this is what calculations show us if we consider all these constraints, that from a total potential of 600, we will go down to about 100. And this is very important, that we can start thinking about how to at least realize these 100 in order to increase the forest area, and with that help to come up with these hundreds of gigatons CO2 sequestration that we are still needing. And the last couple of slides, and Alexander said it already, let me stress a little bit my role as the IIFRO president. We look into the boreal forests, very important area, particularly that we did a very interesting study on it, and this was published by the end of last year. This is a top-down view, by the way, on the boreal forest. And we had a look and compared the carbon accumulation in the standing biomass. And we compared here, for instance, Norway, Finland, and Sweden, and we see that the carbon stock, which is the green one, compared to the harvested carbon, is quite massive, and that actually in these always, badly talked about the forestry in Scandinavia, etc., that carbon accumulates even under very intensive forest management. And Finland and Sweden are maybe the best examples here. And we compared here, of course, all countries, and we could show that in Russia, where there is a medium forest management intensity, and Canada, the forest carbon stock is basically maintained. It's not increasing. It's also not decreasing. And in Alaska, the stock is heavily decreasing. And guess why? Due to forest fires. But however, we see, what I want to say is that forest management can be key. And we have to think about these harvest, and that we have to do something out of that. Of course, it depends a lot where these harvested products go, if this is a paper production or into a very permanent storage in construction, etc. So this is a big difference. Still, I think this gives some hope, because forest fires can be condemned quite a bit through forest management. This is proven here. On the other hand, we still have to think that this is only looking at carbon, and rightly criticized also by Daniela. There's much more, and I've shown that before. There's biodiversity, there's water, and there's the people on the ground. And with that, I'd like to show the last slide. I think certification can help us in really moving things into the right direction. Unfortunately, there's big room for improvement. If you are looking for certified forest, managed forest, then you have to look for the blue area. And this is mostly in here in Europe and in North America. And unfortunately, absolutely, or almost nothing in the Southern Hemisphere. And this is something we definitely have to work on. And with that, I just want to repeat the most important challenges and opportunities. We have all seen it. Of course, there is this direct land use change caused by man, deforestation, etc. But equally severe are the threats through climate change, these indirect effects, man-caused effects. And we have at the same time these super high expectations we can solve it all. And there's this increased risk for disturbances, and I only showed fire. There's beetles, there are other pests and infestations, there's wind throw, etc. A very long list. And we are terribly late with doing mitigation in order to handle that basically on the paper. Yeah. So, and the opportunities are also very clear. I have shown that we have to support forest transition by identifying species or proveniences that are better and help to find a climate fit forest for the next 100 years at least. Afforestation we have to look into. There is some potential, but probably not that much if you consider all other constraints. Management, I still think we have to stress this is key. And don't forget, and this is something what foresters sometimes don't have on their screen, it is these huge negative emissions that can contribute to reaching a maximum warming of 1.5 or 2 degrees, which I think is completely not considered by some thinking in the headquarters of Europe, like in Brussels. I think here we have to reconsider and simply find more appropriate local assessments where to do what. There are different kinds of management. We can do plantation, we can do close to sustainable forest management. We can protect it, fence it, but then the fire will not stop in front of this fence. We might lose everything, all the biodiversity that we fenced due to a single fire event. So it's something that we have to think about. And yeah, action is needed. Please, let's start. Thank you very much.